I will be sending a video on the topic of what is a time crystal. In 2021, a research team from Adam Mickiewicz University in Poland successfully captured the vibration of a time crystal using a special microscope called the Scanning Transmission X-ray microscope at a very fast shutter speed of up to 400 billion frames per second. The video shows the periodic waving of the magnetic structure of the time crystal. In this video, we will delve deeper into what the concept of a time crystal is, as the process of generating the time crystal in the video requires a very complex knowledge. The existence of time crystals was proposed by Professor Wilczek of the Massachusetts Institute of Technology in 2012. Professor Wilczek, a famous physicist who won the Nobel Prize in Physics in 2004, attracted the interest of many scientists around the world, and research on this topic was actively conducted. In crystals such as ice and metals around us, molecules and atoms spontaneously arrange themselves periodically at regular intervals, forming a lattice structure. A time crystal extends this periodicity to the time axis. That is, it raises the question of the existence of a substance in which physical quantities such as the position and physical properties of atoms spontaneously repeat at regular intervals in the time axis. Normal crystals are widely used in academic research as they are present in our daily lives. If time crystals exist, it can lead to the development of new applications that can utilize not only regular atomic arrangements but also regularity in the time axis. We will provide a more detailed explanation of what a time crystal is. Why did Professor Wilczek imagine such a substance in the first place? In free space, physical characteristics are usually uniform at any position. However, in a crystal, the environment is different between the empty lattice and the lattice point with an atom. Physicists call this type of state where physical characteristics are not uniform in space symmetry breaking. In a crystal, the lattice points are arranged at regular intervals, so it is not completely spatially non-uniform. However, as points in different lattices have the same environment, discrete spatial symmetry exists. As described earlier, conventional crystals are understood to transition from continuous spatial symmetry, meaning symmetry in any part, to discrete spatial symmetry, meaning symmetry in discontinuous parts, by spontaneous change in the concept of space. In contrast, time flows uniformly, and no particular time is considered special, so it has continuous symmetry similar to free space. The Wilczek number 8 considered whether there are substances that also spontaneously transition from continuous to discrete symmetry in time. This substance is called a time crystal. At first glance, frictionless pendulums and springs with weights also seem to have a repetitive structure in time, but they do not meet the condition of spontaneously becoming discrete time symmetry of time crystals. Time crystals are like clocks that automatically tick regularly click-clack without batteries, or like something where the north and south poles automatically swap every second even though there is no change in the magnetic field around them. In the former example, the position of the needle, and in the latter, the direction of the electron spin, repeats the same structure at regular time intervals. Do such time crystals really exist? In 2015, Professor Watanabe of the University of California, Berkeley, and Professor Oshikawa of the Institute for Solid-State Physics at the University of Tokyo mathematically defined this time crystal and proved that it does not exist under the condition that it settles into the lowest energy state. In other words, substances that change their structure periodically in a completely spontaneous manner, as Professor Wilczek initially thought, do not exist. Therefore, researchers searched for the existence of substances that cause temporal fluctuations with periods different from those of the given external force. This is like skipping once with a jump rope, but the rope rotates 2 or more times. In the time crystal initially considered by Professor Wilczek, the rope was spinning without turning the arm, but the term time crystal is also used to refer to substances that vibrate temporally with a period different from that of the given external force, albeit a bit weakened. In 2017, several research groups announced that they had successfully created time crystals. It is known that adding periodic external forces such as electromagnetic fields to a collection of quantum particles and giving disorderly interactions between quantum particles are essential elements for creating time crystals. As a result, it has been observed that the behavior of the entire quantum, such as spin, oscillates stably over time with a certain period different from that of the external force. These time crystals are important in extracting stability from randomness and disorder that normally disturb order. Thank you for watching this video. Please subscribe to the channel and give it a thumbs up. Let's meet again in the next video. Bye.